Hi, this is an example problem on force and pressure from chapter 11. Pause for a moment to read the question. Okay, so we see here that we have a person who's walking and they have snowshoes on, and this question is going to compare what is the pressure that is exerted on the barefoot compared to what's exerted on the snowshoe. Now, to remember, this is going back to just a very basic definition that relates force and pressure. So pressure, which is just a scalar, not a vector, has no direction. It's the perpendicular of component of force divided by the area over which that perpendicular component of force is applied. Now, so we're going to go ahead and use this equation to calculate pressure, P. So our F perpendicular, divided by the area over which that force is applied. Now in this case, we see that the person walking here, right, they've got all their weight on one of their feet. So we can kind of imagine, right, like there's this force, contact force there between the snow and the foot. While the woman is in equilibrium at the moment, so her downward force due to gravity, it's going to be a certain amount here, Fg, right? Of course, the magnitude of that force is m times g. And the upward force, that's the force of the surface, the snow, pushing back up on her foot. And since in that moment she isn't moving upwards or downwards, she's standing there, this normal force here, Fn, has to balance the gravitational force. And so at the end of the day, we find out that the force on the shoe, the force of the snow pressing up on the shoe, the normal force here in this case, I'm just going to call it F, it is equal to mg. And so to calculate the pressure, all we need to know is that we know what the force is, mg, perpendicular force from the snow on the foot. We just need to know what the area is. And it says that her barefoot has a surface area here of 160 centimeters squared. We need to convert that to SI units, so let's go ahead and do that. 160 or 1.6 times 10 to the second centimeters squared. Let's convert that to meters squared. So we've got 100 centimeters, or let's say 1 times 10 to the second centimeters per 1 meter. We're going to go ahead and square that factor so that we get area. And if we do that, well, that's going to go ahead and give us a square this one down here. That's still going to be 1. This one becomes a 4. And so we can go ahead and look at this now. We're going to have a 1.6 times 10 to the second centimeters squared. We'll cancel, that was squared. And then we're going to be left with our meters squared, and we're going to be dividing now by 1 times 10 to the fourth. I just write it like this, 10 to the fourth. Bring that 4 up, make it negative. That's going to give us 1.6. 2 minus 4 times 10 to the minus second meters squared. So to calculate this now, all we've got to do is put in our numbers. The mass of the woman, 60 kilograms. Acceleration of gravity, 9.8 meters per second squared. And the area, 1.6 times 10 to the minus second meters squared. If we put all those numbers in, we'll get a pressure equal to 36,750 newtons per meter squared, or we can also use the units here, pascals. So that's the answer for part A, barefoot. Now for part B, we're going to put the snowshoes on. Now importantly, it says her snowshoe is 5 times greater, the area for snowshoe 5 times greater than her barefoot. So basically we're going to have the same force applied, but now it's spread over a larger area, which is going to reduce the pressure. So for part B, P in this case, I guess I should call this barefoot. And this should be the force, same force divided by the area of the foot with a snowshoe on it. Now, this is again mg, And now this is going to be the area of the snowshoe. It's 5 times the area of the barefoot. So we can just write it like this if we want. And in fact, we know that this whole thing here, that's just equal to this, right? So, in fact, really all we have to do is divide the answer from part A by 5. So 36,750 pascals divided by 5, which gives us an answer of 7,350 pascals. So this shows us how pressure and force are different. They're related, but they're different. And pressure is the thing that is related to rupturing a surface, right? So if you've ever snowshoed before, you know, if you take the shoes off, it's easy for your foot to crash through, break the surface of the snow. That's because you have that higher pressure. But if you use a snowshoe, it spreads the force out, reduces the pressure, and you're not going to crack through that surface. The same idea is why a knife blade is made really sharp. If you want to cut through the surface of something, you need to make it a very small area so that a small force applies a huge pressure. Same idea with a needle, a syringe.